Welcome back to my channel. In this lesson, I'll be talking about how to use our trig function, SOH CAH TOA, to solve questions relating to right angle triangles. Now, in this question, we actually have three things that we're actually looking to solve. So we are going to look to solve R, P, and Q. Now, if we look carefully, that at R is the easiest thing that we can actually solve. We don't really need trigonometry to actually solve R. So even looking at R, is that we could actually look here for we see that we have 30 degrees. Here is my 90 degrees. And we know that 90 and 30 is going to give me 120, and 120 is just 60 degrees less than 180. So here is just actually going to be 180 degrees, subtracting from the sum of 90 and 30, right, which is 90 and 30. That's literally going to give me 60 degrees. So that's really the first part of that, right? So here's going to be 60 degrees. So we look 30 and 60 are 90, and 90 plus 90 is actually 180 degrees, right? And the next thing is that we're actually given two side lengths. Now, if that we don't know one of them, we can't go ahead and use Pythagoras theorem, right? We need to find one, right? And how do we do that? Is that we have theta here being 30 degrees, and we also have another theta here being 60 degrees, right? Which we just found. So the main thing to understand is that we can just choose either of the theta, right? We could just use theta being 30 degrees, right? Or we could use theta being 60 degrees. If we're going to look at, say we're going to solve P first, and let's say, for example, we want to use the sine rule, the sine function rather, to actually solve for P. Using the sine function to solve P, we would have to use the angle that is opposite to P. So here we see that P and 60 degrees are in opposite direction, right? So that is if we want to use sine, right? We already have the hypotenuse. And how do we know again that this is the hypotenuse? Because we see that here is the longest side, and we also know that the hypotenuse is always directly opposite to the right angle that is formed right here. So if we want to use sine, if sine is one that we prefer, we can use it. Once we have the opposite side and the angle, once we have these pair, then we can actually go ahead and use sine, given that we know our hypotenuse. So that is how we actually know when it is to use sine. If we would like to also, we could also look at 30 degrees. If we're going to use 30 degrees, then we actually, if this is my opposite, then here would be the adjacent side to 30 degrees. And that is going to make P now be the adjacent of the angle 30 degrees. So let us see what that is really saying, with all of that. So let's say I'm going to choose 30 degrees. I'm going to start with here, 30 degrees. So it means that I'm going to use theta. I'm going to say that theta is going to be 30 degrees. And the side that is opposite to theta is Q, right? But we don't know what Q is. So this is how we start off our reasoning. So we say that theta equals 30 degrees. And the side that is opposite to theta is Q. Q is unknown, right? And when we look, it's not Q that we're solving, we're actually solving P. So P now, if there is the opposite of this side, P now would have been the adjacent. And the idea is that the angle that the side that we're trying to find must also be included in the formula. So although P is also unknown, we are trying to find P, and P would have been on the adjacent side, right? So that is how we actually do our reasoning. So P is what we're trying to find. So that could have been X in some other cases. We also know that we have our hypotenuse. Our hypotenuse is given. So all of our data, we actually write it down. So our hypotenuse here is going to be 10. So what takes in theta, adjacent, and hypotenuse? We already know that that's going to be cos theta. So we know that the cos of, we said 30 degrees represent theta, and we said that is equal to P over 10, right? Now, the idea is that we're dividing p and 10, and we need to keep p on one side of the equation. So the idea is that we need to remove 10, so we're dividing 10, so we need to multiply to remove it. And if we multiply it here, we also have to multiply it here. So these are going to be cancelled out. So now we have 10 times the value of cos theta, which is 30 degrees, being equal to p. So in typing that in the calculator, we just simply type in the cos of 30 and then say equal, and then we times it by 10, which is going to give us 8.66. Right? So P now is actually going to be equal to 8.6. Or if I roll it off, you get 8.7. Rolling it off equals P. Now let us actually see, for example, how it actually works. So we're going to look at something interesting with that. Now, if I, for example, said that, all right, the persons who like maybe prefer to use sine, let's say I'm going to use theta. So we said that theta would have been 60 degrees if we're going to use sine. So theta is 60 degrees. We already know that the hypotenuse is actually 10 centimeters long. And then we have to include the unknown in our formula. And our unknown is P, right? And P is opposite to theta being 60 degrees. So the theta being 60 degrees, P is on its opposite side. So therefore, we have the opposite, we have the hypotenuse, and we also have theta being 60 degrees. So that calls for our sine. Now, let's say I'm going to now actually do my sine now. So we have sine of 60 degrees is equal to P opposite over 10. Then we say that 10 times the sine of 60 degrees equals P. Now the sine of 60, when you punch that into the calculator, so the sine of 60 is literally going to give us the same answer as the cos of 30, 0.866. So, and 0.866 times 10 is going to give me about the same answer as 8.7 is equal to P. So that's literally how these two actually work hand in hand, right? So if you realize when theta is smaller here and we use the cos to find P, we actually got 8.7. But when theta is bigger and we end and P is on the opposite side, we use sine, and we saw that too tells us that the length is indeed 8.7. Right? Very interesting stuff. All right, so we're sure then that P is going to equal to 8.7. Now, if we have P, we could have just simply used Pythagoras to solve it, but we're not going to use that. We're not going to use Pythagoras. We're just going to go ahead and use our trig ratios. We can use any one of them. Let's say we're going to go back with sine. We said that, how do we know if we're going to use 30? So we pick one of the angles. That's the first that we did. And let's say we choose 30 degrees. If we choose 30 degrees, we ask ourselves, where is Q? Where is Q on the side of theta 30? It is on the opposite side. So opposite. And we also know that we have the hypotenuse. So we have 10 centimeters to be the hypotenuse. So there we have it. So we are going to use sine therefore, because the formula takes in opposite and hypotenuse and sine is, and theta is sine. So sine theta, which is sine of 30 degrees, is equal to opposite, which is the Q is the opposite, and the hypotenuse is going to be 10 centimeters, or just 10, right? So the sine of 30, what is the sine of 30? So the sine of 30 is actually 0.5. So sine 30 is 0.5. So Let me just use a different color marker. So that is 0.5, right? Let me say that that's equal to the opposite over the hypotenuse. Then again, where we have this 10 here, is that we actually get rid of this 10 because we're trying to solve for q, so we would multiply both sides by 10. So in multiplying both sides by 10, this is cancelled, that would cancel, and 10 times 0.5 gives us 5. So q therefore equals 5. So q would equal 5 centimeters. So remember to put in your centimeters where necessary, right? So your correct units and degrees were also necessary. All right. So that is how we actually use our trig functions to actually solve a problem where we have to find two side lengths. So that's just one aspect of it. If you want to see how we actually do tan, we would actually, it would be the same thing. Let's say, for example, let's say we didn't know what this length was, for argument's sake. Let's use the same diagram. And let us say that this, for example, was 8.7. Right? So let's say that this was 8.7. Just going to use a black marker. So let's say we didn't know this side, right? Let us say that, sorry, it's not that we don't know this side, right? This side could have still be present, yes or no, right? That could have still be present, right? But let us say that this wasn't there, maybe it just wasn't there. And let us say that we have well, here, what did we say? Q was 5 centimeters. Let's say we're trying to find P. Now, if 10 is there and we have this length, it's natural a person will think to go ahead and use maybe Pythagoras, or maybe use either cos or sine to find P, right? Because we also have theta. But in a case wherein your tan is going to be required to be used, then it's most likely that you're not going to have the length of the hypotenuse, but instead you would have one of these. So you would have one of these other short sides. You would have either one of these, the length of one of these, and one of them would have been unknown, and then you would also have theta, right? It could also be that theta is the unknown and you also have the both sides. That too, you actually could find the angle by dividing the two sides and then finding the tan inverse. We're going to be also be looking at how to find angles. But let's just look at this when we're trying to use tan to find P. Now, as I said, this could be there or it could not be. It doesn't matter, right? Which I believe you understand. So we're actually going to use tan, right? Now, if I use tan, we have the choice of 30 and we have the choice of 60, right? So in this case, we could actually use tan 30. If we use tan 30, the opposite would have been 5 centimeters at the top, right? And P would have to be at the bottom, right? So we could have used tan 30, but I'm actually going to use 60 because, and I'm going to tell you why I'm going to use 60 in this case. The reason for that is because I want the opposite, which is P. I want the unknown to be on top, and the known one, which is the adjacent side, to be at the bottom. So you know that if you're looking at theta being 60, 5 would have been the adjacent side, right? So the tan of 60, so obviously we're going to multiply both sides by 5. So here's are going to be cancelled. So we have 5 times the tan of 60 degrees equals P. So looking at that, the tan of 60 degrees is 1.735 something. And when we times that by 5, timesing it by 5 now, we actually get 8.66, which is literally the value 8.7 that we got earlier, right? So you can see that it literally gave us the value of P to be 8.7 again, right? Just to use tan, but just to for us to actually see as well, where we could have said that tan, we're going to use tan and use theta to be the 30 degrees. We would have done something like this. So the opposite side would have been the side that we know, and the unknown would have been P. So the idea that I said again now is that we literally, if the unknown is at the bottom, we could go ahead and just simply swap these two. So P would be here and tan will be here. It's really transposition, and we would actually multiply both sides by P, right? So P would be removed from here and P would be right here, and then we would know, because we're multiplying P and tan 30, we would know 1 to solve P, so we'd have to divide 5 by tan 30. So that's how it actually works. So in just a nutshell, we're just swapping these two. So we're gonna, where we see tan 30, we're gonna say P equals 5 over tan 30 degrees, right? So we know that tan 30, so as we said, tan 30 is, I'm just gonna round that off, right? All right, so, all right, so tan 30 is gonna be 0.57. I'm gonna put 0.58. So P equals 5 over 0.58, right? So let's keep it at that. So 5 divided by 0.58. So let me just type it again. 5 divided by 0.58 is going to give me the same thing, right? So we got 0.8.6. Well, because we round it off, that's why the whole thing about the decimals. But if you were to keep the values, you would have gotten it more accurately. So basically, we see here that P equals again 0.87, right? Basically, right? If we had kept, the values, the decimals, we would have gotten it more accurately. But it doesn't change the value of P. You know that it's about 8.6, 8.7. 8.6 more, 0.86. Sorry, 8.6. So P would have been like 8.6, and basically the same answer. I know you get the gist. So it's still 8.7. So that's how the whole thing works in finding a side length, right? Now let us actually look at when we use SOH to find an angle. All right, so let us look at this example. So we have angle X, we also have angle Y. We have one side being 8 centimeters, and this side, which seems to be the longest side, is 12 centimeters, right? So solve angle X and Y. So X and Y are angles, right? Now, the first thing to note is that here would be the hypotenuse because here is the longest side. Also, it's right opposite to the right angle. So we know that here is the hypotenuse. So already we see that we have the value of the hypotenuse. Now we also see we know another side, right? And the fact that we know another side, we could actually use Python to find this side. However, we're not going to really do that at this moment, right? But what we'll be focusing on is finding X and Y. Now, I'm going to start off with solving X. Now, if you look, when it comes down to X, the side that is opposite to X is this side right here, in which we have no values for it at that in that space. If we had a value, we could have used sine to find this, but because it's the value of opposite is not present, we cannot use sine to solve this. As we said before, that this is the hypotenuse, so therefore it's obvious that this is the adjacent side. So the obvious answer to use is that given that we have the hypotenuse and we have the adjacent, we're going to have to use CAH, which is cosine, right? So we're going to have to use the cosine function. So let's just write that now. We have cos theta. So theta in this case would have been x, right? Because here the 8 centimeter, right, is at the adjacent of theta being x, but at the same time it's on the opposite of theta being y, right? So the fact that here is the adjacent of x, we put the adjacent of x, which is a over h, and h as we know it is 12, right? So we're going to divide that into our calculators. So dividing that into our calculators, we have 8 over 12. That's going to give us 0.666 recurring. So we're just going to have the cos of x equals 0. We're just going to have 667, rounding that off, right? Now, if we look carefully, is that we want to find x. X is what we're trying to find. Now, if we look, we have cos of x. We need to get rid of this cos right here. We need to get rid of it. Normally, when we're getting rid of something, like for example, we have like 4x, right? We're saying that the cos is like it's multiplying the x, right? So we would say like the 4x, like the 4 is multiplying x. So in order to solve x, we would actually divide both sides by 4. So get rid of this 4, and in doing that, we will divide both sides, right? And that would actually give us 4 into 12 is 3, so x is equal to 3. Now, we could have actually looked at that a little bit different. Now, this 4 right here, 4 is always 4 with a power of 1. That's just equals to 4. But 4 inverse equals 1 over 4. So if we look carefully, is that technically when we have a problem that we're trying to solve for x in the case of 4x equals 12, technically we could have said that all that we're doing is multiplying both sides by the inverse of 4, which is 1 over 4. So we would actually be multiplying both sides by its inverse. So this 4 will be canceling that 4, and then as we know, when we do cross multiplication, 4 into 4 is 1, 4 into 12 is 3. So x equals 3. So having that same concept in mind about the inverse of 4, we would actually apply it here. We won't really put it to say 0.667 over cos. That is not the way we write it. What we write it, is that we just simply remove the cos and say that x equals, and we say that the cos inverse of 0.667. And what does that equal? I know we also plunge that into the calculators. Well, I could just simply keep the value of that in my calculator, and then for some person you will see shift. I think some calculators have second function. So I press my shift and then the cos button right here. So I got the cos inverse. Notice you see the -1 right here. So the cos inverse of that answer will give us 48 degrees. Could actually round it off nearest tens, we're going to have it as 48 degrees. This 48.2, rounding it off to one decimal place. We're going to keep it at 48. So x equals 48 degrees. All right, so that's how we actually find x. So that's 48 degrees. If we had the value of the opposite, it would have been sine x equals that value over 12. Divide the value on 12, and then you will find the sine inverse of that. Now let us look at y. In solving y is basically very similar concept, right? We see if we look at y, we have the opposite right here. So we have the y opposite on this side. So for y, we have its opposite. Here would be the adjacent. So the fact that the adjacent is unknown, we can't use the adjacent and the hypotenuse. We have to know what we have. We have to use what we have. So in this case, now the 8 is what we have, and the 12. So we will have cos of y. Sorry, I said cos of y. The formula that involves the opposite and the hypotenuse is the sine. So the sine of y would equals the opposite, which is 8, and over the hypotenuse, which is 12. So that's how we would actually do that. So yes, again, if we divide them, we're going to get the same. If we divide 8 and 12, we're going to get the sine of y equals the same 0.667. So that still doesn't change. But what changes is that when we try to find y, y now would have been equal to, remember now we're going to change this sign and it's going to become the sine inverse or sin inverse of 0.667. Therefore y equals, so we're going to put 8 divided by 12 again. So we have 8 divided by 12 for a second function, and then press the sine button should give me the sine inverse, and that should give me theta, which is 41, basically 42 degrees. So I'm going to round it off to 42 degrees in this case, because it's 41.8, so that it's closer to 42, right? So y would equal to 42 degrees. So here would be, so we said 42 degrees, 48, and here would be 42 degrees. Now if we were to look at it, if we were to add them, right, 2 plus 8, that's going to be 10. Carry the 1, 1 plus 4 is 5, 5 plus 4 is 9. 90 and 90 gives us 180 degrees. So that's literally how you actually do it. So remember that these should be written in degrees. So here is written in degrees, and here is also written in degrees, right? If it's a case wherein we knew this side, let us look at Pythagoras. Just a brief moment. Is that if we wanted to use a tan inverse, well, in this case, we would have to have this side length, right? So I'm just going to use, let us say, all right, I'm gonna use the Pythagoras to find that. So to find one of the short side in Pythagoras, we take the longer side square, which is 144, minus one of the short side, which in this case is going to be 8, and 8 squared is 64, right? We take the value of that. So 64, 144 minus 64 quickly is going to give us 80. And the square root of 80 is actually going to give us, the square root of 80 is literally going to give us 8.9, or just let us call it 9. So this opposite side right here would have been 9 centimeters. So if that is the case, then we should actually arrive by the similar answers. So if this is 9 and this is 8, say for example this wasn't known now, so we never had the hypotenuse, right? If we were to use the tan now to find it, we know that, so the tan of x, it could be the tan of x or the tan of y, right? So the tan of x would actually equal to 9 over the opposite of x would have been 9, and the adjacent would have been 8. So that's how we would have it, right? So that's literally going to give us the tan of x. So 9 over 8 is going to give us 1.125. So we would have the tan of x, which equals 1.125, right? 1.125, and then we say that x would equal the tan inverse of that answer, 1.125. When we hit shift and tan, should get close enough to the answer, right? 48.3, which was 48.3 is basically 43. So it was basically 48 if we were to round that off, right? So it's still 48, so x equals 48. Now let us look again now, because we also have y. If we wanted to find y similar, we would realize that we are going to get a similar answer. So let us say we have the tan of y, and say that the y now, the opposite for y would have been the 8 in this case, and the adjacent for y would have been the 9. So here you realize now that there's literally a twist. So you now have to say 8 divided by 9, which is actually 0.888, or you could just simply say 0.89, right? So tan y equals to 0.89, and then now to find y, we would actually say now that y is equal to, remember now we're going to take tan, will be the tan inverse of 0.89. So y then would actually equal, so we punch this into the calculator, so keeping that there, the tan inverse of this is going to be 41.6, which we know is pretty much 42 degrees. So there you have it. It still gives us the same answer for tan. Right? So thanks again for tuning into this lesson. Hope this was very informative. Please remember to like, share, and subscribe to my channel. In my next video, I'll be talking about how and when we use our cosine and sine rule. Alright, until then, take care.